So starting in the distribution directory for GWM 2005 and going to the data directory, we find dwater-sv, state variable. This is a version of the dwater problem that uses state variables. Opening the GWM file, we see the decision variable file, objective function, variable constraints. The head constraint file is not here. There are no head constraints directly through the head constraint file in this problem. Instead, we see the state variable keyword and associated file and a summation constraints file. The decision variable, objective function, and variable constraints files are unchanged from the original version of the dwater problem. So let's take a look at what is in the state variable file. So here it is, the state variable file, and the second line indicates the number of head state variables, and a state variable is defined by a name, in this case the B1 through 10, a layer row column location, and a stress period. And the way it works is that during the course of a ModFlow, of a GWM run, at the end of any ModFlow simulation, the state variable will be assigned the value of, in this case, head at this cell location at the end of the indicated stress period. One can assign multiple state variables to the same cell location and different stress periods. That would entail multiple state variables. So for the dwater problem, we've defined a state variable for each of the 10 head constraint locations. State variables are also available for other properties of the system. In this case, there are zero additional state variables, but it is possible to define streamflow state variables. That would be the nrvar index, and storage state variables. And not shown here, but there's a fourth possibility, which is drain state variables. That would be the drain, the value of a flow from a drain, as modeled in ModFlow. Now that we have the state variables defined, we can go ahead and use them. And that is done, in this case, in the summation constraints file. Here is that file, and we're going to impose head constraints through this process in this file. So we define 10 summation constraints, and they are each assigned a name. The first one is headcon 1. It has one term. That term is that state variable B-01, which is a particular cell, with a coefficient of 1, be less than or equal to 50. This, of course, is equivalent to the head constraint statement that the head at that location must be less than or equal to 50. This is, of course, repeated for each of the 10 constraint locations. Let's take a quick look at the output for this problem. Here we see the decision variables, which are unchanged, and here we see the state variables, which are shown with the name, location, and the stress period in which they are available. And of course, this is a steady state problem, so it's all stress period 1. Objective function is unchanged, as are the variable constraints, and here come the summation constraints. So again, 1 times the value of state variable b-01 must be less than or equal to 50. And that's repeated for each of the 10 state variables. Moving on to the solution, GWM reports after the first base flow simulation the value of the state variables, in this case they're head type state variables, associated names, and the associated values, which are in the neighborhood of 70 feet. And it then lists, as before, the status of the constraints, and of course for this problem none of the constraints are met under the non-pumping condition. When a solution is obtained, the optimal rates for each flow variable are reported, and this is the same as it should be. It's the same solution that was achieved using the head constraints file. We also see that the state variables are reported. And so we have the actual values of head directly reported. Some of them are exactly 50, the binding constraints, and the others are a little bit less than 50. The output then continues much as we have seen. GWM then does a final run using the optimal flow rates and again reports the state variables and the status of the constraints. This episode has provided a very brief example of the use of the state variable capability. Other examples are present in the drain example problem, the stream flow example problem, and the storage example problem.